Okay. So how are things going with you?
I haven't tried any of because the first two lessons I didn't understand, so I don't know how to do any of them. So I
Okay.
didn't do any of the.
Okay. Should we look at the first couple of things together
Okay.
and see if it makes sense? Do you have questions? I'm going to bring them up, so I'm going to share the screen.
Okay.
Okay?
Anybody else on the call? Or is it just you and I?
It's just you and I. There were two more. Oh, here's Nancy. Okay.
Okay.
I was just going to say there were two more people who might come, but they said not sure.
Just a second. Let me get some.
Hi, Nancy. Can you hear me?
Yes, I can.
Excellent. I can hear you too. Are you okay with us recording this?
Yes, that's fine.
Okay.
Am I supposed to see anyone else?
Uh, there is Ira here. Ira, how do you say it?
Here, Irene, you can say it. My father is going to come also. He wanted to listen in.
Excellent.
Wonderful.
Hello. I'm Maria, and okay. So, Nancy, there are three of us here, and Ira asked a question. She said she doesn't know how to start yet. So what I am going to do, I'm going to go to the first task and see if we can get Ira started. And Nancy, how are you doing?
Well, we did the first few lessons, and we just worked on them as long as he was interested. The two fractal ones went great, and then we had a lot going on with school, so we kind of took a little bit of break because I was hoping to sit in on the first call, but that didn't work out.
Okay. Okay, so before we start, let's do a bit of just short introduction. So I'm Maria and I lead the course, and I also do the course with my teen who is 16 and having fun with it for umpteenth time. So Ira, maybe you can talk about yourself just a bit, and then
I'm sorry. Oh, my name is Irene, and I have a almost 5-year-old, and I wanted to find some ways to make math fun for her because it doesn't seem to come naturally to her. So that's why I signed up for this class.
and Nancy, would you like to talk about yourself?
Yes, I live here in the States. We're in Georgia. My son is just turned 8 years old, and he's very interested in math, but he's really a builder. He wants to construct things, and he's kind of bored with math at school. He doesn't like the worksheets and things like that.
Okay, okay. So I will say a few words about fractals, and then Nancy, maybe you can talk about how you did them, and then we'll see if we can get Irene started. Okay. So we're looking at this picture now. It's Yelena's son. Being in a virtual world and making a fractal of himself. So, Irene, do you see how that is made? So there is a kid right here, and instead of hands, there are kids again.
Okay.
And then this second level, his name is Mark. So the second level Mark also has little tiny marks instead of hands. And they also have marks instead of hands, and so on. It keeps going for a while. It's a toy in the Museum of Mathematics in New York. I went there once and played with it as well. Spent a lot of time actually playing. It was fun. So does this make sense to you how it's made? Do you sort of understand how you'd be able to draw it yourself?
What does it show? I don't understand. What does it tell the kid? I guess I don't know what fractal means.
Okay.
Can you give us definition of fractals?
definitions. Okay.
Or maybe you can say it in. Do you speak Russian? Can you say it in Russian? What that is?
Fractal.
Fractal.
Fractal. It's the same word in Russian, but with a different stress.
Okay. Yeah. Okay. 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 Maybe we can explain what the fractal means.
Okay.
I don't know.
So, Nan, do you understand what fractal means?
Yes, yes. We drew pictures of them. We had some other little kids here for a play date, so they were all drawing them and making, whatever their favorite picture was, where they were just instead of doing the one little girl was actually doing the snowflake fractal, and of course my son was doing the tree fractal, and they were comparing them, just basically repeating the picture on its edge over and over and over again, increasingly smaller. I don't know a better way to explain it than that, but they did get the concept of it.
Mm-hmm. Irene, can you still hear us? I don't see your camera,
Yes.
but
Yes.
okay. I am actually going to draw a fractal right on top of me right now, right here. So there is a little drawing program in Hangouts, and I will talk as I draw because maybe it will make more sense. So I'm going to draw it sort of on my face because that's where it lets me. So I'm going to use this letter Y as the base of it. The base is that is a piece that you repeat. So a fractal has a part that repeats and repeats again, and the whole thing is the same as the part, as any part you take. So it's something that has parts similar to the whole thing. So right now it's only one part on my face, so this Y structure. So I'm going to repeat the same structure, smaller at each tip. So here it comes again, and here it comes again. So now we have the same structure repeated. Are you with me so far?
Yes.
Okay. So I'm going to make another level. We talk about levels of fractals. So I'm going to make another level of repetition. And I'm going to use still another color. And at the tip of that structure, I'm going to attach this again. So here, here, and it's imperfect because I'm drawing with my mouse, but you can imagine it perfect. Oh, it got moved around. Can you imagine the parts attached in proper places to the tips?
Yeah.
Okay, so I'm going to screen share again. So now, can you imagine that I keep going and going and going with it until infinity?
Okay.
Okay. So this would be an example of a fractal because the parts, so I'm going to circle a part here. Oh, I see why it got detached. Okay, I'm going to circle a part here. So this part with red and purple. So do you see how this part, if we went all the way to infinity, this part here to infinity would be the same as the whole thing because it starts with a Y, it goes smaller and smaller and smaller and smaller. And the whole thing is like that too. It starts with Y, goes smaller and smaller and smaller. So it's this magical structure where the whole thing is like the parts. So I'm going to remove that and I'm going to make an even simpler structure. So here is a line, and I am separating it in half, and I'm separating what's left in half, and I keep going. Okay. So it keeps going to the edge, sort of. Oh, it doesn't draw well. Okay. Why? I don't know. But imagine, maybe I'll do it with paper. So here is paper, and imagine a half of a half, a half of a half, and so on.
Okay.
So if we zoom in at that end, it is the same structure. It's a halves, 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 halves. So the end part of it would look the same if we zoom in as the whole thing. That's what a fractal is. I'm going to screen share again to show another part of the fractal that shows that zoom idea very clearly, the substitution fractal. Okay, so it has this, it has the owl piece, so it keeps substituting in. But I wanted to look at the simpler one. It has this nested doll piece cut. So this is a Matryoshka doll cut through, or X-rays of a Matryoshka doll. It's by Radiology Art, so it's X-ray. So can you imagine just taking this tiny small part, but it keeps going and going and going to infinity. So if you zoom in at the tiny part, everything will look just the same as it was before. Can you imagine that?
Yeah.
Okay. So that's your basic idea of a fractal. And you can make them by branching things. Well, you won't make the whole thing because the whole thing is infinite, right?
So this is just to introduce a child. The question is, why do they need to know this? So it's just so we show this to a child and say, oh, by the way, this is called a fractal. It's just this sort of a base for how multiplication happens. I don't really understand. I mean, I don't know fractal, but I don't really understand how this ties in with multiplication or how this will help. Yeah, it's fun, but I don't really know how to write, but why they need to know that. Yeah.
Okay.
Yeah, how to explain to them? Do we just say, okay, this is fractal? Remember, is that how it's done, or?
Well, the question is, what do you want to achieve? So I want to hold on to that question because it's a big one. I want to ask you, what do you want to, what are your goals with your, with you doing it, with your child? Wait, you have 5-year-old and?
I have a younger one even, a 2-year-old.
Okay. A 3-year-old, right. So what are your goals with your children? What do you want in mathematics? So I'll leave this question for you, and I'll go to Nan and Nancy. What are your? I'll go to your question, I guess, because we talked with Irene for a while. So I'll go with you for a while.
Okay. Well, actually, I can actually ask a question about those two first lessons. When we were going through the lessons, we were really focusing on how math is prevalent. It's everywhere, ubiquitous in our world, and that we were really trying to talk about how beautiful math is, and the fact that I thought the lesson was about patterning even more so than infinity, but maybe it wasn't. So we talked about patterning, we talked about patterns and fractals in nature, crystals, and we did not actually go into infinity too much because I wasn't sure that he really understood the concept of things having no end.
Some people, you said your kid likes to build, and some engineer kids don't like infinity at all.
Oh, okay.
They just say, oh, it doesn't really exist in this world. The universe ends, the 3 fractals and everything, so let's just build some levels and patterns. So maybe you instinctively. Okay. So
Um,
it's
So
okay.
we focus more on patterning, that
Mm-hmm.
math is ubiquitous, and that there's a lot of beauty in math. That's pretty much what we focused on the lessons. We also went online and looked up a lot of images on Google for the Drost effect, because he thought that was really interesting. All the
You
art
like that one?
people had put into their photos.
Mm-hmm. Okay.
We also tried to have him build in Minecraft.
Mm-hmm.
He was able to do the simple trees, but he really didn't get the concept of how to do something more complex in Minecraft. You know, because everything's the blocks. But as soon as he got some of his structures up into the air, you know, because you can build into the sky as well,
Mm-hmm.
that seemed to go better. But again, there was no, after a certain number of levels, he was done. So.
There is a thread on the forums. If you scroll down on the first page, there is well, that's where your questions land if you ask a new question. It's called Multiplication Lounge, and somebody started a thread about Minecraft. So there may be tricks for repeating the whole structures.
Oh.
So you can, for example, if you build a branch of the tree, you know, with the whole things, you can take that whole thing and repeat it.
Oh, that would have been much easier, yes.
So there may be tricks like that, and Minecraft people would know, and we do have some Minecraft people in the course. So I wonder if you post in that thread what you've done so far, maybe a couple of screenshots, people would come. But yeah, so interesting that you went there. Okay, so do you have a question of where to go next or any sort of question?
Well, I would really like to hear a little bit more about the next couple of lessons.
Mm-hmm.
Anything that we can do to make the lessons a little more physical, where he can actually get his hands into them. We haven't actually done those lessons yet.
Mm-hmm. Okay. Okay. Well, I'm going to screen share again, and I'm just going to highlight the physical parts of them, okay? So, I mean, you can do, everything has hands-on parts. So the fractals, of course, you build. With Zoom, you can build, let's see. Do you see my screen?
Yes, I do.
Okay. So you can do a lot of measurements, and if you go to Universe Scale, if you go to the Universe Scale software, you see how they built this Zoom system, and
Yeah, I had a problem with that because I'm on an iPad, which doesn't do Flash, so I am going to have to get access to a laptop before I can do that part. So I was not able to get into Universe Scale.
okay.
Little hold up on my end.
Okay, okay, so this one doesn't work. So are they both Flash? This number sleuth too? Okay, could be this thing. XKCD examples are just static. They're pictures you can zoom in a bit. So one thing to do is to build an actual model like that, but maybe with objects, collect objects. So you can build, this is logarithmic scale model. So you can build a model like that. When I say logarithmic scale, does it make sense?
Yes, yes.
Okay. So, and then you can actually get the machines that zoom, you know, just a magnifying glass or a telescope, a microscope, and get a field trip. One fun thing that we did once was a 1-inch field trip. When you get a good magnification and you just look at the tiny thing, whatever you can find within 1 inch of your yard, maybe a bit cold for that. You can probably only find snow depending on where you live, but you can go on that 1-inch field trip. So do these things make sense so far?
Yes, it does. I like the 1-inch field trip.
So you can basically, it's about orienting yourself in space, and you can get very physical. You can climb things. You can measure with your body. You know, you can climb and measure with your body length. You can make stop motion photography when you lie down and measure with your body length, like 1, 2, 3.
Mm-hmm.
Okay. So with sequences and series, so this one, this one is you can model it with paper, or you can model it with objects. It's about building these things. I actually, where did my thing go? Okay, it's on display. I have toys like that made out of wood. So, and designs like that can be made out of paper or wood, and can be, if you make it large enough, you can physically manipulate it, put it together, cut it apart. So you can make these puzzles and then find different ways to put them together. So something like that, if you make it even just out of cardboard or even thick paper, and then put it back together again. So that's a physical way of doing it. And a lot of children like to do this on spreadsheets where they divide again and again and again. So they program the next cell with division by 2. And then, or something like that, and see what happens, how it goes to 0 or how it adds up. Does it make sense?
Yes.
So far? Okay. This video at the end, Infinity Elephants, a lot of kids like to draw like that. So you can just see what she does in the video. When I do this in groups, I show this video, and usually immediately as I show the video, kids start to doodle even before it ends. And you can, if your kid likes large objects, you can doodle like that in chalk outside, or use a whiteboard to draw large. Would he draw on a whiteboard?
Yes, but we also have sidewalk chalk. That would be a wonderful thing for the driveway.
Right. So, and of course, multiplication towers are all physical. We just did them with my kid today. My Ray also likes to build, so we did this activity. It's all about building. Okay.
Okay, great.
So I hope, does it answer your question?
Yes, that was very helpful.
Okay, so a bit of a review. Okay, I'm going back to Irene. Irene, you had some time to think of my question, so I want to go back to you because I want to match my answer to your goals with your children. So what do you want to achieve with your 2? What do you hope will happen if everything works perfectly?
Number 1, that they think math is fun.
Mm-hmm.
Number 2, that when they, since they're so young, when they do get these subjects in school, that they already are familiar with it, so it's not going to come as a shock. So it's not going to be hard for them.
Mm-hmm.
So 2 goals. That 1 is math is fun, so that they like it.
Mm-hmm.
And the 2 is that it will be easier for them later on in school because they're so young, right? So.
Okay. Well, that helps because now that you say that, I think your 2 questions, what do we do with fractals and how do we explain, how do we connect to multiplication, makes sense, more sense in the context of it.
Mm-hmm.
Okay. So first of all, let's look at how it connects with multiplication. So I'm going to screen share that very first task, the fractal tree. Okay, and we're going to try and search for multiplication in it together. So, okay. Okay, so this is the first level of it, where there is one mark. Okay, and at the second level there are 2 marks. And what about the third level? How many? So 1 mark, that's the largest.
4?
Mm-hmm. This one's 1, 2, 3, 4. Mm-hmm. How about the next level?
Okay, so it's 2 to the power then.
Mm-hmm. Yeah, so each next level it doubles because we get two hands for each person.
Okay.
So it's powers of 2.
Mm-hmm.
This is a very foundation of well, multiplication and everything because it's such a this structure doesn't have any numbers except for 2 and doubling. It just doubles and doubles and doubles, doesn't have anything else. So it's kind of your gentle introduction to multiplication. Okay, so if we go to the second week and look at some pictures. Okay, so let's look at the owl. So what's going on with the owl? What do we have here? So let's just focus on the eyes. So here we have 2 eyes, and here we have 4 eyes. And at the next level, so what's going on here with the owl?
Mm-hmm. To the power.
Mm-hmm. Yeah, it's powers again, powers of 2 again. So it's 2, 4, 8.
2 to the power of 4.
Mm-hmm. It's powers of 2 again.
Mm-hmm.
So it's a different way to represent them. Now, you can, of course, you can do different fractals. So with this one, it's actually powers of 9. So because 9 pieces are substituted at each level. So that's the first level is 1. The second level has 9 little chocolate pieces. And then it gets hard to see. It's a Sierpinski fractal. Okay. So fractals have powers, which is, do you see the connection to multiplication from that? Okay.
Yeah.
Also, each task has a write-up that says how is this multiplication. But the main idea here is that you show groups, the idea of groups. So the levels of fractals are like groups, or this branchings or substitutions are groups. So 2 eyes of the owl, or branching in 2, that's your groups. When you have this triangle fractal, you substitute 4 parts there, that's your group. So the child learns this to pay attention to groups and units. And this is a very fundamental idea to multiplication. Now, so the connections to school subjects here are powers, which you named, so exponents, powers, power structures, groups and units. So all the third one about zoom and measurement, it has powers for measuring. So powers of 10, like the metric system, like there are 10 millimeters in a centimeter, 10 centimeters in a decimeter, 10 decimeters in a meter. It's the same fractal idea. So we move on into measuring with units and into doing sequences with units. And we go out with zoom and powers, and we go in with the substitution when we slice in the force activity. So the connections here are powers, units, and groups. And that's all about multiplication, units and groups. If you think of our number system, it is based on powers, right? I mean, our base 10 system. So a number like 257, you have to understand power to even understand what 100 is and why 100, kind of. So this is the foundation of our number system too, and it all helps. It helps with to understand the structure of numbers. You can connect it to units. So does it make sense?
I guess I'm going to try and then see what happens. It doesn't exactly, thank you. It doesn't exactly make sense, the last part, but we will try. Thank you.
I think you can try and see what children like, because a part of it about fun, children usually like fractals. They're cool, you know, this idea of something growing and growing is fun. Children like the Zoom games, the activities. They just like to see how the universe works like this. They're very big things, they're very small things. And they just usually like, it is a powerful ideas. So children like to feel that power to build these things. So if you try, you'll probably have more questions, and then we can discuss those, right?
Thank you.
Okay. Okay. Let us go to Nan again and see if we can have more questions here. Nancy, do you want to talk about more things?
Actually, I really like the way you explained the groups and units to her. So that actually helped me a little bit as well. And I was just sitting here trying to think of like all the different things. I do have access to a telescope. Now I need to find a microscope. And so I've been kind of like thinking over all the different things that I can go around the house and dig up.
A lot of museums and children's museums let you play with microscopes. So maybe you may usually somewhere neighbors or friends have some. A lot of people play with them these days. But also, it's not quite as fun, but there are virtual microscopes. And actually, our cell phones now have a bit of a zoom.
Yes.
So any camera or phone or smartphone usually has that power to zoom in and out. I don't know if you ever watched the science fiction or read the science fiction The Diamond Age, but it had this smart book that worked as a telescope and microscope together with encyclopedia. And the book was written before smartphones, but now we have that really. So it's kind of like the science fiction object that does both, and pretty well. I mean, once you get the idea, you get the imagination going. But yes, your son is into engineering. Yeah, the idea of units. I'm glad you picked this one. It's so powerful. If our kids understand units and units of units, that's, I mean, they're so far ahead already in the world of, well, algebra really, because algebraic variable is like a unit of sorts.
Yes, yes.
And so operating on variable is like dealing with units. So you play this way, you develop your algebraic reasoning. And that answers Irene's question about school connections or schoolwork connections too. So a lot of this prepares algebraic ideas, or calculus ideas, of course.
I think at this point, I'm just wanting him to really enjoy it and to see the connections, the patterns. And I think that this will click for him later in school, that he'll see it come together in a different way when he's in a classroom. So we're just trying to get the foundation down now.
I would like to say something for both of you. It's a tool for clicking and for patterns for noticing, going deeper. So Irene, it will help with connections and with school connections, and then it actually helps with fun. So everybody wants fun and everybody wants connections, but so what you do is you kind of observe your kids and you see what words they use or what they really like out of fractals. So Nancy, what did they like? What did your son like about fractals? Like, what was the part he really liked?
He really liked that he could take whatever he wanted to make a fractal out of, so that he didn't have to use the same picture that I was doing. I did one with a daisy to show, every petal of the daisy was start of a fractal, or excuse me, the new start of the segment.
The node, kind of, the point, okay.
Yeah, but he wanted to go someplace completely different, and he started building pictures with the Minecraft creeper on paper.
Oh, yay!
Creeper over and over and over again, attaching him. So he made a tree fractal out of the Minecraft creeper, and that occupied him for a long time. He really enjoyed that. The fact that he could choose what he wanted and make it his own.
Okay. And so for me, this is, I'll do a little bit of a scavenger hunt together. So what this super cool thing that you can choose whatever you want and use that. What mathematical idea does that represent for you? How would you call that feature?
I'm not sure. What do you mean?
Well, when I say scavenger hunt, it's like, does it remind you of anything? Okay, does it remind you of anything in mathematics? This taking an object, any object, and substituting it or using it.
My brain's not searching for math terms. It's not coming up with any math terms.
Okay. Give it a bit more time, maybe 30 seconds or so. Where in mathematics is, if anywhere, and you can just free associate, where in mathematics are you ever doing something like, where you can take different things and use them up, or you can substitute one thing for another, or what does it?
Algebraically?
Huh?
Are you talking about like algebraically?
For example, where in algebra have you seen that? I mean, my question does not have a single answer, just it has infinitely many answers.
Oh, okay.
Just to put your mind at ease. It's a very open question.
What is she wanting me to connect with?
Right. Don't try to read my mind, because I don't have anything in mind. I mean, I have some things in mind, but you'll probably have different ones.
Well, I think for him, it will be very helpful for him to be able to experiment to replace different values in his calculations. And also, when I think of calculus and it's constantly changing, that was probably a concept that he'll connect with later on as well.
So you
see that it's a calculus concept.
So you find two things, and I was not thinking of any of them. So it's very cool to see how different people find different things. So we'll go with yours. So you have this idea of change, right?
Yes.
That's big in calculus. I mean, it happens in a lot of areas of mathematics because change can be studied systematically, and applied science engineering. So biology is all about change. Okay. Okay. So the idea of change is kind of um, uh, key here. So you can change one thing for another, and you named that in expressions or formulas or something algebraic, you can substitute, you can replace one thing with another, like one number with another, so on, right? Did I get it right? Okay. So the first term is change, and the second, what did you say? Plug in, replace? What was the word?
Just experimentation, where he could try different values to see how it was going to work. They're kind of incorporating each other.
Okay, different values, maybe variables values. Okay, so what you can do now that we've had this conversation, you can put the word change on a little card and say, well, that's something you like to do. So you put this word, I don't know, on the fridge, or if you have a bulletin board, maybe have a little special bulletin board just for that. And then you put the word value, because that's what you put in. So your creeper, his creeper is a value, your daisy is a value. And you can put numbers. I don't know how many points he used for the creeper, maybe the corners, so 4. Did he use 4 or 2?
He used 2 because he was trying to make a creeper tree.
A creeper tree. Okay. Yeah. Okay. So a creeper is a value. It has a value of 2. Daisy quite a bit more. So you can have these cards with your keywords like value and change. And next time you do an activity, you can ask yourself and ask him, do you see things changing here too, like that?
So just keep referring back to previous lessons in building, make the connection between them?
Find what was sweet for you. Put a word to it. And then go back to that sweet word.
Okay.
So this way there is a connection and continuity. And that goes to, Irene, it goes to your question about whether you name things like fractal and so on. I like to use some words, but I like to see which ones of them children pick at all, if they do, and then follow with those, and then come back to those that children like. Children usually like the word fractal. It's easy enough, but strange, So that's one way to kind of have this fun connection. That is fun because you follow what your child likes. So did it make sense what I did now with the scavenger hunt? It didn't for a while when I asked you that question to name it. But does my question retrospectively make sense? If I ask you to find the names again, do you know what I mean?
Yes, I do.
So that's a technique you can use to increase fun, basically. Okay. Irene, I wanted to call on you. I know your microphone's muted now, so come back with us. And I wanted to see if what I did now made sense to you for searching for ideas that make sense to you or your children.
Yeah, we'll have to. We'll have to do the exercises, and then we'll see what happens.
Yeah, it almost like we have to do it for ourselves. Find words and ideas that make sense to ourselves, and then with the children separately as well. Okay. So would you like to discuss more things, Irene? Pose some questions, get ideas going.
Uh, I want to do the first two activities first, the ones that you were saying, and then see how it goes. I haven't looked past. I was stumped when I saw the first two. I thought, I don't know what this is. So then I just waited until I could speak with you guys.
Okay. Okay. Um, so I hope it helps. Okay.
Thank you.
Nancy, so back to you. Do you have more questions or concerns or just topics to talk about?
No, not really questions or concerns, but I do have like a topic to discuss. I was really kind of surprised when I would read over the lessons and I would think that I was going to help my son, guide him through this. But I was really surprised when he would simply be more attracted one part of the lesson than I expected, or be bored by a part of the lesson that I thought he would find really exciting. So I found it was important for me to really be a little bit more on top of the lessons so that we could switch according to what his interest was. So the first two lessons went very well. When we got to Zoom, we started off like we tried to like play a game where we would pretend we were really, really small, and what would the objects on the table look like if we were that small or that large. And I thought that was kind of interesting, but he was actually bored by it. So, and then when we tried to get online, I couldn't access because of Flash.
Okay.
So kind of like stopped me because I wasn't more prepared to pick up with something else to keep his interest going. So I think and then life happened, so we got busy, but I was really looking forward to the sessions so that I could have a better understanding of what else I could do if something just didn't click with him. What could I go on to? So I found that I really had to have like 3 or 4 different ideas to get him, which one was going to be attractive to him versus guiding him through a lesson, because he didn't really want to take it like a class. He wanted to sit down and have fun and do something interesting. So that's why I've been like making notes on all these wonderful ideas you've been giving me, so that I can make sure that I have not just 1 or 2 things that we're going to do, but 3 or 4 things that we're going to do. Does that make sense?
It makes sense. And maybe we should package it better, like almost little cards that you can print out and take. Like, try this, doesn't work, take next card.
Oh, that would be very helpful.
Let me try something for the next week, because we actually have it in the text, but it's not packaged like that. I mean, you can find it in descriptions. So yeah, I see what you're saying, and it makes perfect sense to me. So going forward, maybe I'll try to produce it. I don't know if we'll get it in time in this course.
Yeah.
But you can, as you read through the descriptions, you can make cards for yourself with little notes, like what activities are all there.
Yes.
There are usually about 10, actually. That was our goal, to have anywhere from 8 to 10 different things to do for each topic. So you can find a few that you think fit your son, and then have cards prepared, like just short notes. Here is what we do first, here is what we do next. So as you read the next topic for yourself, you can make that happen.
Yes, I think I will definitely do that, because I was picking out things that were interesting to me and that I thought were going to be interesting to him. And then I just don't think that I had enough when I sat down with him. So if I had some notes and had 4 items to discuss with him instead of just 2, then he would have enjoyed it more as well. But I mean, he has enjoyed it.
And it's okay. I want to say it's perfectly okay if you spend 5 to 10 minutes at it. It's not supposed to be long. It doesn't have to be this grand lesson for 2 hours.
Do you think that they're getting enough from just a 5 or 10 minute lesson? Are they just supposed to get the concept and move on?
Okay, here are the things. There are different levels of exposure, and Actually, I want to point out to Irene that this is a huge part of fun. How do you make it fun? Don't make too much of it, okay? So there are different levels of exposure. You can spend a lifetime with fractals, right? And people have. People spend their whole career studying those things. So, okay, that's extreme case. Then where is short enough or long enough? It depends on the person. So we go for exposure, right? So some new idea, some new principle. This principle, this idea that you name, that you can take any object and make a fractal out of it. Okay, powerful idea. How long does it take to, to get that? Maybe long, maybe 2 minutes. Okay. Then if there is love and interest, you can go deeper. You can go find more of those activities around the topic because there are some in comments that people describe what they did. You can follow the links. We have some links there, so you can see, you can Google things. So if there is interest, you can go back and spend more time. But minimally, you just get this exposure, something sweet happens, little, maybe get one word out of it, put it on the bulletin board, and move on. So it's totally okay to have short exposure.
Okay, then I guess we're doing fine because we've been doing 20 or 30 minutes and maybe just pushing it too much. So yeah, maybe he's got it and something else.
20 minutes is very good. This is actually the one that we get a lot from parents, especially younger kids, because parents expect, like, all of us have this preconceived notions of what a normal lesson is, right?
Yes.
But what you can do is, if you are interested in the topic, if you think it's rich, right? If you think it's promising, you can put some reminder up, like you put his creeper tree up on the wall, right? Somewhere on the fridge. And then you can search for something else, and a week later you say, oh, your creeper tree reminded me of this. And you spend another 5 minutes.
Okay, yes. Just keep relating back. I like that.
So there is some continuity. This is more fun than 2 hours at once, and you get less tired, and it's more organic, so to speak. But you want to remind yourself to do it. That's why I keep saying, put up words, put up pictures.
Okay.
Just so you are reminded of it. So have some sort of one. I read that essay. This lady said, I strew my math around my house. I'm strewing mathematics around the house. So she like throws it all around. Well, that's a bit radical, but I like to just frame it and put it up and put it on the walls in little frames, or just hang it up. So if you see my wall behind me, my wall of awesome. So I put things up there, and I have a bulletin board here. I have something hanging up there. So I do that, and my kid does too.
I like that wall of awesome.
He likes the wall of awesome. Thank you. I am quite fond of it because it's awesome. Okay. Okay. So have this continuity. And Irene, it's my same advice to you. Take small pieces of it, expose your little kids to small pieces, a few minutes at a time, and see what they enjoy, right? What a few minutes they enjoy. And then later follow up on that joy and meaning with some more, right?
Thank you. Yeah, we'll try that.
Okay.
Lots of good ideas. Thank you.
Okay. So you almost become, and I think you will like it, you almost become a scientist observing your own children. Like, what is it they paid attention to? What they noticed? What they like? I mean, you know what they like, but what they liked in that new context.
Okay. Yeah.
And then you, as a grown-up, you do what I did with Nancy about, does it remind you of anything? So does it remind you of any mathematics?
Mm-hmm.
So
Well, I like the value and whatever that you guys were talking about. Actually, that more than anything helped me realize, because I'm more into algebra than anything else. So that was like, okay, yeah, I know what you're talking about. Yeah.
okay, okay. So you will connect what your children do with what you like, of course, because you know what you like, you know what you know, and this is perfect because this way you bring them into your world too. You invite them into what you like. So it connects and it makes it more interesting for you to do things with them. So, I mean, a lot of baby games are boring for grown-ups. A lot of young children's mathematics is boring for grown-ups. So one of our goals is to have interesting mathematics for grown-ups to do with young kids.
Bringing it all together.
All together as a family, exactly. Okay, so can you make the same time next week? Same Sunday time?
Yes.
Okay. And Nancy, can you make the same time next week? Is it a good time for you?
Can I just switch over and I will tell you? Give me one moment.
Mm-hmm. You can go back to the time you tried originally at 2.
I'm pulling Google back
Okay.
up.
Okay.
There you
So
are. Yes, I can do the same time. That's fine.
the same time, okay. So then I will see the 2 of you next week, same time. I'll send the invites just the same way. And bring your questions, ideas, anything. We'll talk. Let me know if you want me to prepare something. If you have question ahead of time and want me to prepare, you can email me anytime.
Okay. Thank you.
And we can connect during the week, and I'll see you on the forums, of course. So we'll start the algebra week next week. Irene, that's your week. Okay.
Oh, I have to finish the first week first. So.
Okay. Take your time. The forums will stay up, so they are not going away. No worries. And I'll be sending more materials and videos and everything. So just write anytime. Okay. Has it been helpful for you, this meeting?
Yes, thank you.
Yes, Mary, I've really enjoyed it. Thank you.
Okay, good. I hope it helps you help your children. That's the most important thing. So let's talk next time. I'm really looking forward to seeing how it goes for you.
Thank
Okay,
you.
Thank you so much.
thank you. And I'll talk to you next week.
Okay, thank you. Goodbye.